Linear pair. A linear pair looks like this. Let's call this angle 1 and angle 2. Linear pair are angles that are side by side on a line together. And linear pairs make supplementary angles because they're on a line, they add to 180. So you say that angle 1 and angle 2 are supplementary. Angle 1 and angle 2 are supplementary because they're on a line, side by side, together. Okay, we're right there, so we're also going to do the definition of an angle bisector. You have some angle, and it is bisected, which means that it is cut in two. Bisect, two parts. We're going to call this ray that's bisecting it BC. When you have an angle bisector, it makes the two parts congruent, and that's how you can mark it. Because I don't feel like writing out letters, we're going to call this angle 1 and angle 2 again. If you have a bisector, it is slashing that angle in half, and it makes the two parts equal to each other. So you get to say that measure of angle 1 is equal to the measure of angle 2. And the reason for that would be the definition of a bisector. Because as you see right here, BC is a bisector, is an angle bisector specifically. This is a part you would say in a proof. That's the important part. Bisecting, the two parts are equal. Let's say you have some segment AB with midpoint M. So you're told that M is a midpoint. Of AB. If M is a midpoint, then it's cutting that segment in half. So AM is equal to what? MB. And you would mark those congruent. So put the little slashes. AM equals MB. If you're told something is a midpoint, that's what you should go to right away, that the two parts are equal. So I'm literally going to write exactly what it says, which is that BC bisects angle ABD, and picture info. If you want to actually write out what the picture says, you can do that. I'm not going to, because it's in the picture. Given. Okay. Okay. Addie Roush, what could I say?
Measure of angle BBC equals the measure of angle CB.
Yep. CBA. Okay. So because you have an angle bisector, the two smaller angles are equal to each other. This is because of the definition of an angle bisector. I'm going to highlight it if you don't see it. X is what DBC is equal to. So it'll go right there. CBA is equal to 2x minus 75, like Emma said. It goes right there. So now you write a new line, but replacing those two things. Thank you. So we'll put x equals 2x minus 75. What's that called when you replace something for something else? Substitution. At this point, you just have an equation that you have to solve, which is nice because you know how to solve equations. And you have variables on both sides, but you don't like that, so you have to move your variables to one side. I would move the 2x. It's positive, so how do you move it? Subtraction, good. Minus that 2x. If you want to show your work, you can, but remember you don't have to technically, because what we care about is the part that's in blue. It'd be negative 1x equals negative 75. How did you get that? Subtraction. Property of equality. Okay, so last part. This is not subtraction, it's multiplication, so how do we get rid of multiplication? Division. X equals positive 75 because of the division property of equality. I'm going to draw on this diagram. You have BC bisecting ABD. So BC is this one. It's bisecting this larger angle, which I'm going to highlight in green. So that's one. The other bisecting thing we have, they overlap. So BD bisects CBE. Do you see how they overlap? Okay, why might it make sense that ABC would be equal to DBE? Any thoughts? So because BC bisects ABD, you're going to write that measure of angle ABC. What does ABC equal because you have a bisector? CBD. So I'm looking at the green one. It cuts the green angle into two parts, ABC and CBD. You can write another one, but for using BD, that bisector. Yep, we're going to do it on the same step. So looking at the blue angle, you have two parts. One of the parts is CBD. Measure of angle CBD. What is that equal to? DBE. It's the other part of the angle. These two parts are equal because you have the bisector in the middle. Okay, this is because of the definition of an angle bisector again. Because you have the middle part the same, you can connect the first, the first to the last. So your last line in this proof, yay, is what you're proving. ABC is equal to the measure of angle DBE because of the transitive property, which connects the first thing to the last thing. You're done. Remember we talked about if you can, you should mark your givens in your diagram. This one's a little bit weird. You're told AC equals BD. It Since those overlap with other segments, I'm going to mark that by doing like a little bracket to show that these two pieces are congruent. We're going to write an equation for AC. You cannot say that things are equal just yet. You have to use segment addition postulate. Part plus part equals whole. So I can say that AB plus BC equals AC. You want to write an equation for AC. You also should write an equation for BD. Part plus part equals whole. Someone give me my equation for BD, the other one. We're using segment addition postulate. Aiden, what is it?
BC plus CD
Yep.
equals BD.
Yep. Okay. You have your two equations with letters. Now you need to substitute if you can. This one is different. You are told that AC equals BD. That's important. You just wrote two equations that are equal to those things. So that means that you can now take those equations and set them equal to each other because AC and BD are equal to each other. You get to say AB plus BC equals BC plus CD because they're both equal to AC and BD, which are equal to each other. This is substitution. It's a different kind of substitution than we've done before. It's kind of like systems when you'd say, well, they're both equal to Y, so I can set the two equations equal to each other. The last step we did on our warm-up. You want AB to be equal to CD. Subtract the BC, and you have that. So AB equals CD because of subtraction property of equality. You have AC equals 21 and the stuff in the picture that AB is 3x and I think BC is 2x plus 1. You're a good geometry student, and so you should go to your picture and mark that AC is 21 like this. So you know the whole thing is 21. You know the parts are 3x and 2x plus 1. You do have to do part plus part equals whole. B is not a midpoint. You can't assume that. So we are using segment addition postulate. Again, SAP. Ava, you said it for the last one. So what can you tell me for the segment addition postulate for this one? Part plus part equals whole. Yep. Part plus part equals whole. We've used that equation so many times in the last few days. You know what the parts are, right? You know that AB is 3x. You know that BC is 2x plus 1. You also know AC. What's AC? 21. So you're going to take that and put it here. You're going to replace all three things with what's in your diagram and what was in your givens. And then you just have to solve. So it's now 3x plus 2x plus 1 equals 21. Solve that equation. Your reason, by the way, for combining like terms is just going to be combine like terms. This is substitution, what you just did. You replaced